All right, so this question says a tray contains a dozen each of 3 kinds of cookies. How many different assortments of 7 cookies can Devin select from the tray? All right, so for this question, we're going to have to use sticks and stones, or sometimes it's called stars and bars. And the reason why is because what we're really doing is we're going to say we have, let's think of it as we have 7 cookies, 3, 4, 5, 6, 7. These are 7 cookies. And we want to split them into categories, okay? There's 3 different categories for each kind of cookie, okay? And so these are going to be our sticks and stones. So let's just say, because there are 3 different categories, there's going to be 2 dividers. This is how we do sticks and stones. And for a more detailed explanation on sticks and stones or stars and bars, I can make a separate video for that later. Let's say the 3 kinds of cookies are chocolate chip, sugar cookies, and then what's another type of good cookie? Well, there's so many. But let's just say gingerbread, because that's very different from the rest. Okay, so these are our 3 types. So a lot of times people get confused, like, why are there 2 sticks or 2 bars when there are 3 kinds of cookies? Well, the bars are just that, they're dividers. This would represent 2 chocolate chip, 2 sugar, and then 3 gingerbread. And then wherever we place the dividers would give us a different combination. Okay, so if we were to put this like here and then the second divider is here, well, this just means that there are 4 chocolate chip cookies, there are no sugar cookies, and then there are 3 gingerbread. Oh, did I forget the D in gingerbread? Oh, wow, that's sad. But basically, our answer to this question is just going to be how many ways we can rearrange these 7 stones and 2 sticks. And so the amount of ways we can rearrange 2 different objects, we're going to have to use the choose function for that. So basically how the choose function works is, let's say we had a word like banana, right? And we're trying to figure out, and this is completely separate from this problem, by the way, I'm just illustrating how the choose function works. And we're trying to figure out how many ways can we rearrange the letters in the word banana. Well, there are 6 letters total. So we're going to have 6 factorial, and we're going to divide it by the number of letters that are repeated. So we have A repeated 3 times. So we're dividing it by 3 factorial, and then we have N 2 times. So we're dividing it by 2 factorial. And this would give us the answer to the question, well, how many ways can you rearrange the word banana? Now, we're going to apply that very same logic to this question, except in this case, well, we have 9 different objects. We have 7 cookies and 2 dividers, 7 stones and 2 sticks. This is 9 different objects. Now, there are 7 of the same thing here, and then there are 2 more of the same thing here. So our final answer is going to be 9 factorial divided by 7 factorial times 2 factorial. And remember, a factorial is just, the number times every integer less than it. So 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 9 factorial. And then on the bottom, we have 2 factorial right here. 2 times 1 times 7 factorial, which is again 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you notice, well, the 7 times 6, blah, 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 on the numerator and denominator, they both cancel out, leaving us with 9 times 8 over 2, which is equal to 9 times 4, which is 36. So there are 36 different ways to arrange these sticks and stones, therefore 36 different ways that Devin can select an assortment of 7 cookies.